Okay, here we've got a question, and it says, according to a psychologist, the ability of a person to understand spatial concepts is given by A equals 1/3 root t for t between 5 and 18. Ability doesn't have any units, so we're just going to got units of ability, I guess. T has the units of time in years. So it's the ability to understand spatial concepts as a function of time in years, and this is a fixed domain, which probably means the function only actually applies between those certain years, I suppose, because the brain changes, I guess, if it applies at all. But let's pretend that it does. So, part A, find the rate of improvement in ability to understand spatial concepts when a person is 9 years old, when a person is 16 years old. So the rate of improvement, so that's the rate of change of ability, which is going to be positive. If it was a negative value, it wouldn't be a rate of improvement. So we need to, either way, we need to find dA by dt. And you're probably, to do that, you're going to want your ability in this form, 1/3 t to the half. So dA by dt, bring the half to the front, times it by the third, a half times 1/3 times t to the minus a half. Tidy it up. Half times a third is a sixth, so it's 1/6 root t. Oh dear, right. Oh, nice. Root t, like that, right? Or 1/6 t to the minus a half. I'm probably going to use both of these again, this one right now. So for part 1 it says, when t equals 9, what is this dA by dt? So dA by dt equals 1/6 root 9 equals 1/6 times 3 equals 1/18. So as we wanted it, it is positive, so it indicates improvement. And I can't give it units, I find that quite annoying, but I guess it's 1/18 units of ability per year. But I don't know what the units are, I don't know what ability is measured in. So part 2. We're going to need the same, we're just going to substitute 16 instead. When t equals 16, dA, the rate of change of ability with respect to time, equals 1/6 root 16. Well, root 16 is 4, 6 times 4 is 24. Again, units of ability per year. Right, so now we're on to the next part. B, explain why dA by dt is greater than 0 for all 5 to 18. So we know that dA by dt equals this 1/6 root t. Now root t as a function kind of looks, right here, kind of looks like that, with the square root of 0, 0, square root of 1 is 1, square root of 2, 4. You don't include the negative values or it wouldn't be a function. So this is root t, this is t. But remember, we're only interested in 5 to 18, so 5 probably somewhere around here. 18 is not a great scale, but let's assume it's over there. We're only really interested in the sign anyway, so in that region, for 5 to 18, it's just positive the whole way, right? So root t is always positive. So root t is greater than 0 for all t between 5 and 18, inclusive. So, well, 6 root t must also, if you times that a positive number by 6, that must still be greater than 0 for all t between 5 and 18. And then if I divide 1 by a positive number, it's positive divided by a positive. So 1/6 root t must be greater than 0 for all t between 5 and 18 years. So that mathematically explains why it's true, right? Comment on the significance of the result. think I've got one more clean board here. So, between 5 and 18 years, the ability to understand spatial concepts is always increasing because the rate of change of ability with respect to time is always positive. Always increasing. Okay, so for part C, it says explain why d squared a by dt squared is less than 0 for t between 5 and 18 inclusive. Comment on the significance. So remember, dA by dt, the first derivative, was 1/6 times t to the minus a half. So yes, we kept this index form because we're going to use it now. So d squared a by dt squared is going to be power to the front minus a half times 1/6 times t to the minus a half minus 1. Minus a half minus 1 is minus 3 over 2 because 1 is 2 over 2 to the minus 3 over 2. Tidy it up, equals minus 1 over 12 root t cubed. So a negative bit meaning in the denominator, the 3 over 2 meaning square root it and cube it. Okay, so that's our expression for d squared a by dt squared. So again, you need to say why is this thing always negative? Well, root t, as we know, is greater than 0 for all t between 5 and 18. So this is root t. So root t cubed, if I cube a positive number, well, that's definitely going to still be positive, is greater than 0 for all t between 5 and 18 inclusive. So then if I times by 12, so 12 root t cubed must be greater than 0. Timesing a positive number by 12 is certainly not going to change the sign. For all t between 5 and 18. It's good practice this, especially you have to do a lot of this sort of thing with a calculus option, so it's good practice even though I can see why it might be a bit boring. And then so minus 1 over, put it all together, minus 1 over 12 root t cubed. Well, that's a negative divided by a positive, right? So that must be is less than 0 for all t between 5 and 18. So that explains why it's true. So comment on the significance. Well, so we knew that the positive first derivative meant that your ability to understand spatial concepts is improving, or from the years 5 to 18, but the negative the negative second derivative indicates that yes, although it is improving, it is slowing down. So rate of improvement is slowing down. In fact, let me just, rate of improvement in ability to understand spatial concepts. Is slowing down between ages of 5 to 18 inclusive. Okay.